All right, so we'll start the show.
Let's do it.
Thank you very much. Welcome to .NET Rocks. We're here in Bulgaria at DevReach. This is day 2.
Second to last session. The show is almost over.
Yes. And yes, it is Friday.
It is Friday. It's almost time for beer.
Or rakia.
Or rakia. Yeah. Or whatever your poor adult choice liquors.
All right, well, we're here with an esteemed panel, and we're talking about web performance, so I'll start with Ken. Just introduce yourself, who you are, what do you do?
My name is Kent Alstad. I'm from Vancouver, British Columbia, Canada. I work for Strange Loop Networks. I'm the CTO of Strange Loop Networks, and our company's reason for existence is to speed up websites. So, this is something that is very dear to my heart and something that I have a fair amount of practical experience in.
Hi, my name is Steve Smith. I'm currently Executive Vice President with Telerik in their Services Division. And in the past, I've written some courses on using performance and scalability tools with Visual Studio for Pluralsight and consulted for clients on improving the scalability of their applications.
Hi, I'm Paul Carvalho from Canada, just outside of Toronto. And why am I here?
Draw a blank.
No, I am not a developer. I'm a testing consultant, quality consultant, and I'm currently working for a company as a quality architect.
So you get to see speed problems go away, hopefully, from slow to fast.
I make it as part of the picture.
Yeah.
Yes.
Looking at an overall test landscape, speed is only one piece of the puzzle.
Yes.
Yeah.
To be fair, I think that's what Kent and I try and do as well. We don't try and make it get slower.
I'm not so sure.
I'm curious, do you ever have performance as a requirement? Like, as a tester, have you ever come to a project where they've said that our page load speed has to be on average X or Y? Like, do you have them? Normally I see performance as, if it never is stated, it's only when it's not there everybody's upset. So, but so it's expected and it's really hard to deliver, but do they ever give you the actual requirements?
No.
Nice.
No.
Just wondering.
No, it's a great point, because I'm a big fan of service level agreements, and this stuff I've had to author over the years, and we want to set hard numbers around transactions will take no longer than 10 seconds and those sorts of things. I think the big challenge is that often we're doing those negotiations at a business level and never actually talking to the developers, the testers, and the operators about, oh, by the way, you're committed to a 10-second transaction.
And also, load testing and speed testing, stress testing is different than in the wild, where you really need some sort of telemetry to get real-time feedback.
Yeah, I think that one of the strangest lessons for me over the last 6 years of doing performance is that it turns out that measuring performance is as difficult as getting performance. We have spent as much time on beacons, different types of testing technologies, different types of load testing technologies, and then collecting millions of rows of data and then trying to figure out what it all means. And so you could state your service level agreement, but does that, is that doc complete? Is that doc ready? Like, what's the actual criteria for what you're going to measure, right? There's so many details that we found that's, not only is deciding that, I want to fix this app, it's not performing is a problem, but how do I measure it and how do I even set up those service level agreements? What tests do I use? That's also very difficult. So it's a very difficult space overall.
But Kent, this is all fixed by the web timings class in HTML5.
It's very much affected by the Heisenberg uncertainty principle, right? Because as soon as you start measuring performance, you're affecting it. And the more you need to know.
I've already been killed by listeners about it.
That.
It's not Heisenberg, it's the observer effect.
Right.
Heisenberg was a different thing.
Oh, really?
Yeah, Heisenberg says I can know the potential of an electron, but not its location, or one or the other.
Sure.
Right. Observer effect.
I will
you
take
watch
your
it, it
word
moves
for
away.
Yeah.
To elaborate on the answer I gave earlier, when I look at a system or help people look at systems in different ways, part of the question of understanding performance objectives or goals or requirements is they know by look and feel it should be faster, but they can't quantify it. And so we use exploratory methods to examine potential risk areas within a system, and that's where it gets to what you were saying, setting up the experiments to gather the data and then looking at it and then saying, what do you feel, and then sort of collaboratively determining what those requirements could or should be within certain thresholds.
Now, as a tester, Paul, you're coming at this from the point of view of I am working in a lab doing a series of tests. I mean, I know from my experience, I think Kent's had a similar one, that we're trying to do more and more instrumentation in the field all the time,
Right.
like collecting every client is sending us back data on performance. Is that, I mean, I don't know how you're working. I'm curious about that, because I mean, I've done a lot of lab work too.
Right. I've been going sort of, as I work with different clients, they have different needs. And we're currently, for the client that I'm working with right now, we're currently setting up a lab and trying to make it more formal. Generally, it starts off with, and what I like from the tester perspective, the outside-in approach, is I'm focused on that end-user perspective. You know, when we deliver this solution, the customer doesn't care what the technology is underneath. They want, does it solve their problem? So I do actually like working from the outside-in approach. And then when I start working with devs, it's like, okay, this area, how can we start to take a look at this? You know, I've got a form here with too much client-side validation. We need to minimize that to streamline the page download times. You know, what sort of technologies do we have available to help us re-architect this particular?
Is there a predefined pecking order of things that you check for when you're looking for bottlenecks?
So I start with a risk-based approach, and there's some general risk criteria that I start off with, looking at things like what are the upstream and downstream dependencies. If something is a third-party tool, or if it's new to the system, if there's no prior history, that's where I might tend to focus on certain things. When it comes to finding relationships under the hood, then I sort of partner with a DBA, or I partner with a senior dev person and say, this is kind of what we're looking for. And we set the direction, and we just sort of meander in an exploratory way with that goal in mind.
Steve, what about you?
Well, in terms of what's the first thing I look for, it's almost always going to be the database or any other out-of-process call, because those tend to be the things that are the slowest in the applications I work with, which tend to be web apps. But I also wanted to, when we were talking about service level agreements, mention that it's often very hard to get enough information to define what the service level is. The canonical example is that you just have the user saying it has to be fast.
Right.
Okay,
right.
great. But you can go beyond that and say, I need so many transactions per second, or each transaction must take less than so many seconds.
Yeah.
But even with that, as a developer, I know I can game that easily, because I can just say, well, it does that when there's one user,
Right.
or it does that as long as I have 10 computers behind it and I max out all their CPUs.
Sure.
So you also have to cover, like, what are my resource constraints? What's the total load of the system?
Yeah.
How many records are in the database at this time? Because the performance of the system is going to vary over time as well.
You're getting right to my point that the measurement of the system is often as complex as fixing the problem. I approach it differently, because often because I'm wrong so often, I start with normally a waterfall measurement.
The sign of a very smart engineer.
Yeah.
Well, I mean, performance is about measurement first, understanding the bottleneck, and our experience when I look at it, so a waterfall is essentially a look at what each network transaction is for a web page and how long it takes. Invariably, most big applications, once they get into the field and are being used, I find that there's an 80-20 rule. Normally 20% of the time is somehow rendering the HTML, and 80% of the time is getting all the resources from the various locations and having the page finish rendering. Now, I know that there's a database problem. That often gets caught by the devs before it even gets out there, because it's,
Sure.
it never really made it. But now we're in the field, and the CTO or the CEO of whatever your big customer is looking at the page, and he's saying it's slow. So you start doing the test, and you start by creating a waterfall and looking at it, and then you start looking at what are the most common culprits. Well, the biggest problem in web performance today, undeniably, is third-party content. And that people got ads where the way ad servers work is there's a bunch of JavaScript, and they say, hey, I want to fill an ad, and they go out and they say, they go to the first ad server, do you want to fill this ad? And they take the information from the client, and they decide, oh no, I don't want to fill an ad, and they go to the next one, and you get imagine that the same page will go, the first hit, you look at it, it has 30 round trips. It has HTML and 29 resources. You hit the very same page again with a different user, with a different demographic, and in a different location, in a different part of the world, and you get 250 requests. And the page is 4 seconds one time, the exact same page on the exact same website with the exact same code. So we found invariably that controlling those third parties, tag management is the, sort of the field of correcting that problem, and there's many companies that address that. Google just released Tag Manager, to try to help with their services 3 days ago, which is, interesting to look at. Bright Tag or Tagman or other companies that attempt to address this in various ways. Some people try to fix all the advertising firms out there and the ad services, which seems like a pretty long job. Like it's a big cycle, and there's
so a real easy test is turn all the third-party ad stuff off
and see what the page
right.
And often you get a very different picture. But surely the first thing to do is to start with that waterfall and find out.
Yeah.
I mean, if you do have a database problem, you're going to see a waterfall where if the page takes 10 seconds, it takes 8 seconds to get the HTML back, and 2 seconds to get the rest of the resources, and oh, I got to go, now I can actually go to the developers and they can do something about it. But if I do the same thing and it's 0.5 seconds to get the HTML back, which is often the case, and the rest of it is getting the resources and rendering them, you could go to the devs all day long and they could correct as many database queries as they want, and it wouldn't help.
Can I ask you to roll back a minute and just sort of define waterfall, which you're talking a lot about in this context?
Yeah. A waterfall is a pictorial depiction of the rendering of a web page.
Okay.
Where imagine it starts with the first row would be calling for the HTML, and normally each row, tools that do this are like web page test or the built-in tools in all the browsers now have the sort of developer versions, and they usually say a network graph. You click on the network panel in any one of those tools, normally built into the browser. It kind of shows you, here's the HTML, then I got these JavaScripts, and it kind of shows you in a sort of time graph, where things are taking, how long they're taking. You can normally go into every request and see, well, how much time was DNS lookup? How much time was content download? And so you can try to figure out, is my problem bandwidth? Is my problem DNS? And you can start to assess what to do.
Well, and the classic one is someone's dropped Google Analytics into the header, and you see this big bonk on the graph where the page comes down, and maybe one CSS came down right away, and then there's this long line. Well, Google Analytics took its time, and then the rest of the page could load. But of course, I mean, that's a digital depiction of the rendering. What the user saw was I hit the page and nothing came up for a long time, and then it all dropped in.
Would it be wise to put that in the footer, perhaps, or does it matter?
It loaded asynchronously after the page is rendered. Yeah, I mean that's the whole. But the marketing guy who wanted Google Analytics didn't know any of that. He just dropped it in the first place. He could put it in, didn't crash the page.
Right. So it's not going to matter to Google Analytics if you put it in the footer.
No.
Yeah.
Well, there's a subtle detail there. Unfortunately, people click away from pages, and the later in the page rendering cycle you put data capturing mechanisms like that, the more likely you are to not capture beacons or not get the information. And from your ad server background, you've probably seen always there's a discrepancy between impressions and what happens, and for the same reason, right?
But if you are just trying to track analytics and they click away before they load the analytics, you probably didn't want to count them as a real visitor anyway.
So the consequence is very low there.
But yeah, like one of the reasons why my background and the thing I look for first is not the waterfall is because a lot of my experience with performance tuning was on the ad server side, where I only have one request, and that's to get that ad back as fast as possible.
So you're basically the guilty party?
Yeah, we blame you.
For a
Just
while.
wondering.
So like 10 years ago when I first started doing ad software, we did do stuff with document.write. And when you run document.write on the page, everything comes to a screeching halt while you render that, and then the DOM readjusts itself, and then JavaScript continues. These days, most ad servers don't do that, and they do wait. Like essentially, they don't necessarily use jQuery, but they essentially operate on the same way as an asynchronous call on load or on ready. So when the document has loaded, the page is probably already rendered, and then the ads pop in. And if you are looking at a waterfall and you see that, and all you look at is the total time, that total time might be, whatever, let's say 5 seconds. but the page might have rendered to the user with all the stuff they care about, not the ads, in 2 seconds. So it's another SLA thing where you might want to say, is the page usable? Don't worry about the ads, right?
Yeah, that's in the web timing spec on IE. They have first paint is a measurement you can use, which is and I think it's interactive or document interactive. So you can use that. We actually, you talk about measurements. In web page test, which is another tool that does waterfalls and tests, automates browsers and does this sort of stuff. They'll do a video, and often that's what the most useful thing is looking at a video and finding out when the page was really ready, because all the numbers are lying. It didn't, everything was async, and none of the measurements really mattered, and the page was ready in 1 second, and there was just stuff going on for 8 more seconds. You were loading resources for other pages, and it wasn't really that bad,
I mean,
right?
You're getting into this concept of what the user perceives as finished or fast, and what the measurements show.
Correct. And as developers trying to solve performance problems, we're all about deferral and asynchronous behavior to solve the problem. Let the user be free to let that page be usable early, and the measurement systems just haven't caught up with the fact that that's going on. So you implement these techniques that actually make the page more usable faster for the user, but your measurements don't reflect it at all. So you've actually fixed the problem, and the measurements don't tell you that you've fixed the problem whatsoever, which again brings me back to the fact that measurement is one of the key problems in this, this whole equation.
I can't let this talk go without bringing up your amazing discovery about caching for 1 second.
Oh, right.
In the SQL Server, in the database.
So one of my favorite demos that I would do in talks for performance would be to run a load test on a simple page that in your application is maybe your home page or something else that's getting hit more than once a second. And if you don't have any kind of caching involved and it's hitting the database or something, there's a certain limit that you'll hit with how many users per second it can, or requests per second it can support. And if you turn on caching and you kind of go to the business users and say, is it okay if I cache this for 10 minutes? And they say, yeah, okay, it doesn't change that often. You can get much, much better performance. But then the interesting thing is that if you take that 10-minute cache and drop it down to 5 seconds or even 1 second, oftentimes you'll get exactly the same performance in terms of requests per second as you were getting with a 10-minute cache. And the users are seeing fresh data because you've removed the bottleneck off your database. And so maybe your database can only do 40 requests per second. As soon as you put on a 1 second cache, your database is now doing 1 request per second, which it can do all day long.
So there's no excuse for not doing a 1 second cache.
In many cases, but it will still be an issue if those users need dynamic content separate from one another.
Yeah.
Right? So if each one needs to
in less than 1 second?
Well, individualized, right?
Yeah,
even if it's only for a second, I don't want to see your bank account info when I'm looking for my bank account info.
Of course, yeah.
But for common content, certainly.
For common content, right.
I really have to emphasize that is a great technique not only for the performance, but for the simplicity. Often when people start using caching, they believe, and I feel wrongly so, that what they need is some sort of concurrency mechanism that keeps their data, if the data changes, then they kick the thing out of the cache and they build this elaborate system.
But that's just developer thinking. We like the logic of cache it till it changes. It seems logical.
Right.
Right up until you have 10 machines, and it changes in the database, or it changes on one of the machines, and now you've got to build a distributed system to get everything up to synchronize it. And it's never exactly right, and now you're spending, the project that was to cache for 1 second, which took 5 minutes, now is a 3-month project of concurrent caches. Or no, you know what? I'm going to deploy memcached on it. It just goes on and on. It just goes on and on.
Or you could have just done time-based cache.
And time-based caching actually works like a dream and gives you 99% of the benefit. So I just really love that technique. We call that micro caching. And it's a great thing to do. And it only applies, unfortunately, on pages that, if you were to use WinDiff on the HTML, are the same for 2 different users, right, who look at that page. And how many pages do you look at today where you do a text difference on the pages and they're identical?
.NET rocks.
Our pages are like that.
Every page of .NET
Every
rocks.
page, yeah.
Well, many sites that we experience have, user Kent Alstad up in the top, or
Right,
the date, or anything around that, which causes, forces you to a more sophisticated cache.
Potentially, or you can use Ajax loading or other techniques to make these little islands of dynamic content. As long as you don't care about like SEO and making those things visible to spiders, then you can get around that. But that has more of a performance cost too, because now it's one more request before the page is ready, or it has to go fetch, Kent Alstad to put that in that spot because everything else is cached.
So I'll put a plug in for that technique if you do that. So just be clear what is being outlined here. I've got a page that is mostly static. It's got the date and my name. And instead of having that embedded in the HTML, I have a standard piece of Ajax that goes out and fetches the unique data from the server as a separate call. And thus, the page is actually identical from one page view to the next. And I can use my microcache, and that allows you, which it's a little more complicated, and a lot of performance turns out to be adding complexity to your app, and that's a problem.
What if it's all dynamic? What if you're Gmail, and you're doing something where everything is dynamic on the page?
And you're not going to do any output caching.
No, you're not going to do any output caching. What's the next place you would look?
Now you're in your business layer. You're doing as much caching with database logic cached in the middle tier in memory.
Yeah.
That normally, or you're getting a memcached or some a caching layer in front of you or in front of your database, or that your app can use.
Unfortunately, there's no silver bullet in that scenario.
No, unfortunately, performance. I mean, it's a good business to be in one sense, because it's fraught with difficulty. Like, most people just don't want to get into it because it's a deep topic, right?
Yeah.
Well, and it's sort of like regular expressions, what they say. I mean, like with caching in particular, it's one of those things that's easy to shoot yourself in the foot. So, if you've got a performance problem, you want to solve it with caching, now you've got two problems, because you've got to figure out how the caching works, and it's easy to get wrong.
Well, and I've seen cache misimplemented that still gave some performance benefits, so they wanted to keep using it, even though it wasn't actually working right.
That's really common. So I mean the caching is probably the biggest performance benefit.
We can get you the wrong data quickly.
Yeah,
Yes.
we can get you the wrong data quickly, and actually we can make it really fast and wrong.
Yeah, fast and wrong.
Yeah, we're good at fast and wrong. But
It's wrong, but at least
caching
it's
is a great
fast.
technique. Let's just the one thing to point out, that it's foolproof. If you can get the right data cached, ultimately that's a great thing.
Should we skip over to load testing for a bit? Because I think we're hitting an interesting inflection point on the way we do this kind of testing. And I really see two species of it. I'll throw this at you, Paul, that there's the A/B testing. Is the new version faster than the old version? And then there's the question that real people ask, which is, will this website survive Black Friday? That, will it make it through the weekend? Do you deal with that question, and how do you tackle it?
I haven't had to tackle that particular question. I have friends who have. So within the testing community, there's a series of workshops called the Workshop on Performance and Reliability, or WOPR for short.
Nice.
Yes, with references back to the good old war games.
Yeah, no
movie.
kidding.
And
Performance, the only way to win is not to play? Is that where we're going? Uh-oh.
yes. And in each one of those workshops, we tackle a different aspect of performance and reliability. And when it comes to load testing, so there's different interpretations in terms of what it means to different stakeholders, and I often ask for clarity. So one of the things you mentioned, the A/B testing, I refer to that more as benchmark testing.
Right.
And there are things that you can, like tests you can automate, that will tell you from build to build if the performance of certain things have deteriorated over time. And you can set alarms on that when the differences become too great. And those are nice to just get automated and not have to think. I prefer to play more in the stress testing kind of environment, which is a fun way of doing load testing to find what that breaking point is. And then you can scale back and say, okay, now how can we look to solve this problem in a different way?
Right, we're good up to here, kind of thing.
Yes.
The way Boeing bends their airplane wings till they snap.
Yes.
Just to know that it's strong enough.
That's how they do like maximum strength Tylenols. They give you enough to kill you, and then they back that
back
off
it
a
up
little
a
bit.
little.
I found that very, very expensive to do on large websites. I mean, a lot of websites that are going to survive Black Friday, where a lot of load test tools will do on each client maybe 5,000 virtual users, and you look at what your site's doing on Black Friday, and you're all of a sudden at 100,000, or some sites are way above that, 1 million concurrent users. And we use a device called a Spirent Avalanche, which is a hardware load generator. But there's techniques available to you to how can you stress out your real back end, not your sample back end, but your staging back end, but your real back end, or as close to that as you can, with a huge load. And so there's all sorts of ways to go about that. Maybe you stress out your database and just hammer it as though there's that many users, and then use 5,000 real users. So now I've got my database, my middle tier. I've written programmatic code to make it think there's 100,000 users, and I've used the load test tool for another 5,000. I take the metrics as though my back end is under this enormous load, and now I want to see what 5,000 users who are using a back end that thinks it has 100,000 users work like. And just to cut the cost, because simulating 100,000 virtual users is a very expensive proposition, like hundreds of thousands of dollars expensive just for the software, right?
Right.
So it's a tough problem to get yourself in a position. And then the question is, if you normally have tremendously different gear in production, and you're trying to extrapolate from my staging environment, because running what I just said in production is like, it has to be an awfully slow day, and for you to be able to get a test like that in, because it's pretty dangerous, right? You're really, so how do you now have to extrapolate from your staging environment, and normally the hardware for a really big site that even cares about Black Friday, the production gear is worth hundreds of thousands of dollars, and your little staging environment is one server and you're trying to make this sort of guess at, well, how does that all translate? So it's a pretty tough job, like that, to really get an accurate. How do you know that you passed Black Friday? I know when Black Friday passes most of the time.
Right. Yeah. Well, one way you could get all that load is just annoy the hacker group Anonymous, and then time that so that you're measuring at the right moment. That's what GoDaddy does, I think.
Turned out they had some problems.
Their strategy didn't work.
The other thing you can do specifically for that is the selling point for all the cloud networks now is to not use your own hardware and just kind of rely on the ability of Azure, Amazon, or what have you to scale. But you can also use that from a testing point of view. If you need hundreds of thousands of concurrent requests, a relatively cheap way to do that, as opposed to setting up your own lab, is to spin up a whole lot of VMs in one of these cloud providers and have them hammer on your system.
And that brings us to an interesting point, which is how do you make your cloud-based web app more performant? What do you do there? I mean, you're in the software, and you have database indexes and things like that, but you really can't throw more hardware at it, can you? I mean, you could turn on more servers, but...
Yes, you can turn on more servers, and you can tune it, of course, right? I mean, if you've got for loops that are doing stuff they shouldn't be, or resources that you're loading before you need them, most of the time, like when I'm doing performance tuning, that's what I'm looking for, is work that I don't need to be doing, or work that I don't need to be doing yet.
But is taking away that hardware layer actually a good constraint for you? Like, does that focus you in on the software more?
I don't usually try and tune at the machine or hardware level. I try and get the fastest hardware I can get, and I suppose I'd be at the mercy of the IT department of whatever client I was working at anyway. So that wouldn't bother me terribly. I'm sure others are more at that level.
So it's really not much difference.
I did see one tweet floating around for DevReach that said, "Cloud won't protect you from stupid."
Yeah, I saw that.
Yeah, true.
So, because I mean, an awful lot of folks are saying these days, well, scaling and performance on websites is the problem, or we have the cloud, just run it there, it'll be fine.
Right, yeah, if you have a lousy performing application and you put it up in the cloud, you're going to have a lousy performing application in the cloud, and oh, by the way, you're going to get a big bill at the end of the month because you're going to try and overcompensate for it with a lot of resources, and you're paying by the resource now.
Yeah, I would, my answer to how would I scale the cloud, well, first of all, most of the problem is in not the actual web app returning fast enough. Most of the problem is in all the subordinate resources returning fast enough.
So they're the same problems.
Well, I would use a content delivery network, first of all.
Right.
You know, like I would push all those resources onto other machines, get them,
Yep.
you know, now I want my Azure code running my business logic, and that all it's going to do is generate HTML. There's never going to be any other call coming to that. And then I'm going to start distributing that amongst many machines, and I'm probably going to have to go with some distributed data. Now my problem is going to be at the database pretty soon, or some singleton along the way, right? And I'm going to try to, you know, distribute the singleton through caching or through, you know, geo distributed databases. You know, now it gets harder and harder as you go, for sure. But you know, that's the overall strategy is to start using that network. And I find that it actually works. Like for the most, it doesn't overcome stupid. I don't want to, you know, but you know, you can take a fairly poor performing app to the cloud and use a content delivery network and notice a tremendous amount of offload and a tremendous amount of scale.
And perhaps then that would focus you on your, you know, on your logic, on your database indexes, on those kinds of things.
Right. Now at least you're looking at the load that you've got on your machine is your code, which at least now when you're profiling and you make a change and make your code 50% faster, you're going to realize it. You're not dealing with network saturation or all these other problems that, you know, cloud your view of what's going on.
It's probably worth noting too that there's a difference between performance and scalability, and oftentimes you have to sacrifice one to get the other. So in a cloud environment, like Azure, for instance, a lot of the things that are in Azure, like SQL Azure or even the built-in table storage and things like that, the way that your app on your server and your VM accesses those resources is typically through some HTTP pipeline that Azure abstracts away from you. Now, if you were writing that yourself and you were putting that stuff on your own server, you would almost certainly not go down that path. If you were just worried about performance, you'd put all that stuff in memory on your machine, and it would be much, much faster. Like, you know, we're still talking milliseconds, but it might be 10 times faster than having to go out of process every time to talk to HTTP or to a SQL Azure database. The fastest performing application you're going to get, assuming it has a database, is if you put it all on one machine, because now you don't have any latency hopping. But scaling that then becomes a challenge.
Yeah, there's a very strange and complex relationship between scale and performance, right? Because if you really load up your machines with lots of users, all of a sudden it affects your performance, right? And yet, you know, just having lots of users, you know, if it was all static HTML, it wouldn't make any difference, right? The two start to affect each other, and they're, you know, it's like a Venn diagram where the circles are definitely, you know, there's some the overlap there, but how you test and measure that is, again, you're getting into a complex problem where, you know, is my problem that the code just doesn't run fast enough if there was one user? Well, because that, you know, that's a performance problem. I'm on one box, now I've got a pure performance problem. But as soon as I got more than one user, now I'm creeping into the scale. Oh, 2, that's probably performance problem. 3, 500, oh, maybe. 10,000, oh, well, now it might be a scaling problem, and, you know, my code might just be fast enough and I have to have more distribution. Or, so there's an interaction there which can't be avoided. Like you have to, you know, sit back and architect for it.
And I've found that it's always much, much harder to scale from one instance of an application or server to 2 than to go from 2 to infinity. Getting up to 2 is always the tougher thing. If you've written your application so that everything is tightly coupled to that one machine, you're going to have a hard time getting it on 2. But once you can do it on 2, you can do it on 3 and 6 and 10.
Absolutely, absolutely. And a lesson for me there is always start at 2.
Yes.
Yeah, I don't even like 2. I like 3. You could lie to yourself with 2. I've seen folks stand up a second server really for reliability, but not made the 2 machines weren't configured the same. They hodgepodge that second machine up. But 3, it's just no longer manageable. You better have sort of the discipline to manage those machines symmetrically.
Yeah, the main thing is to make sure that you're ready to be in a farm. Like if you're going to really take advantage of the scale of the cloud, you had better have it work on 2, 3, 4. I mean, that's got to be part of your thinking from day one, or the cloud's not going to help you. You know, that scale is not usable.
Now you have many virtual instances you're paying by the hour that don't scale.
That's right.
Nice.
It's just going to be more expensive, and not faster.
Yeah. Still wonder about actually how we test all of this stuff well, like how we can actually get to a point where we know what's going to happen. I mean, so much of what you're describing is literally you're doing it on the fly in the field.
Well, I found an interesting phenomena happened in the last 3 years, I would say, last 3 or 4 years, and that is that testing, we built all these content-oriented applications, which really every user had their own unique view of an application. In fact, they could choose different widgets. Sometimes they could even code their own widgets, all this stuff going on. And it became really hard to know how the app was going to scale. You could have a set of components that scaled poorly. You could have ones that were good. And what I saw happen was people start using A/B testing in live situations as their test. So instead of deciding that, oh, I am a careful scientist, I can make sure that everything will be in a row and it's going to work at the first time and it's going to work to this capacity. You know, it's like a surgeon. You know, it's nice and clear. Well, another strategy is to say, well, I've got my next version. It addresses the issues that I had. I'm going to turn that live for 2% of my users. And I'm going to use A/B testing to ship all my, and so instead of simulating anything, I'm going to say, well, I've got my new code on one of my servers, and the only people, or the only situation that really tells me anything is live, and I never get any confidence. Like in some apps, I just don't care how much testing you do. As soon as it's live, new things happen, and I don't believe I've gotten anywhere until I actually have live users. So now we see people using and there's whole tools coming out, multivariate testing tools that allow you to release your code to 5% of your users. You watch your main metrics and you decide you're okay because the page view time is the same, the shopping cart abandonment rate is the same, you know, the user adoption rate is the same, and you decide, oh, my code is good and working right. My new release can go to 10% of the users now because none of my core metrics have changed on the users that are using the new code. Risky, maybe, but you know, testing in this sort of artificial environment has its own set of risks as well.
Sure.
And the thing that a lot of people like about this strategy is that it takes less testers. Like imagine what Facebook has to do.
Paul clearly needs a new job.
Well, I mean, I think that there's functional testing, but this is a different type of testing, which, you know, when we're talking about capacity and scaling and load testing like this, you know, it's debatable how much you learn from your artificial environment. I guess that's the real point, is that in some cases you just can't learn enough. And as a result, the only thing you really get the confidence on. I know a lot of people that will not ship their new code without A/B testing. They just don't believe that new release is really ready, regardless of how much testing you've done. And it depends on the app. You know, our application at Strangeloop is intended to work on every single web page on the entire internet. Well, that takes a long time to test before you shipped, right? So we have little choice but to make, you know, we have to make some balancing calls, and using A/B testing to get there is one of the most efficient ways in terms of cost to find out, you know, whether your app has got a problem or scales. And the main issue there is you need two components to make that type of approach work. Number one is an A/B test that works correctly. So that's just a router normally in front of your website that says that 2% of your traffic is going to your new app and your new servers, and a very, 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 very important second point, which is the ability to roll it back at an instant. You know, because you know it's the only reason that type of approach is even acceptable in any way is if you can roll back.
Well, at least you're only knowing 2% of your customers.
Right, and the reality is, if you went with synthetic testing, you might be instead affecting 100% of them, right? Traditionally, what you do, instead of affecting 2%, is you test it in 1% of the total cases, right? But they're the most common cases, though, so we're feeling pretty good about it. And then you roll out to 100% of your users.
And pray.
And pray. And pray, right, yeah. It's release and pray. It'll be a new deployment system we'll come out with.
You had a comment about 10 minutes ago.
Sorry.
It's like, oh, like this.
Well, I found this a really interesting new way to do things and it works very effectively. So I think it's worth taking a look at.
There's wow, there's like 14 questions based on what you were saying. When I'm teaching testing to individuals and to teams, I always make it clear that when we get into the space of performance testing, this is a whole different beast. And using my background from science, I always say that performance testing is the most scientific of all of the others. Is that yes, math is required. There's a little height bar limit. If you do not know statistics, turn back now. And
abandon all hope.
And so yes, I find a lot of value of doing performance testing just on a staging server. As this is a controlled environment. Let's just push the limits of what we can do here. And one of my favorite techniques to get some quick and cheap and easy performance data is to just run a training class. And what you have is you have a group of 10, 15, or maybe 20 people all hitting the same pages at the same time because they're working through the same exercises. And what they're doing is they're putting an artificial load on the system in a way that can simulate certain bounces in traffic and loads in traffic that can give you some insightful information before you even put it on production. And following that pattern, I was able to bring down a financial balanced, load balanced system with just 3 testers. And each one of us had 3 VMs, and we were simulating 9 users, and we just hit the app in certain places, and we actually brought down the database just with the 3 people. And that was valuable information.
Was that an Access database by any chance?
No, it wasn't.
No?
No, it was Microsoft.
Because that was my experience with an Access database.
Nice.
And so there are simple, cheap techniques that you can use just with a few people to gather some quick information before you go and test it on production. Having said that, that is still a controlled artificial environment, and you're playing with thousands of data and users as opposed to tens of or 100,000s of users. And there's definite value in doing that as well. I like to start with the controlled environment first, do the math, a lot of math involved in understanding scalability. But it does give you a preview of what's to come, and oftentimes we've eliminated 80% of the performance issues just by doing the focus tests. But they're focused, targeted tests, not random.
Well, I mean, in the end, the customer isn't random either. They clearly have a path. I guess the question is, how do we simulate what the customer would do well? How do you get that information and turn it into load tests?
Have you guys seen the preemptive analytics tools? That they sort of attach post-compile to an assembly, and asynchronously, without putting any performance hit on your code, in production will sort of profile and measure and send that telemetry back to you. And so that you can really get a good view of what's going on in your app just by using this stuff. And Richard's been doing it in his demos on the road trip.
Yeah, and that's available in production. That's what I really like about that is that, for me, having that production data is so critical. What I want as a developer is I want to see when Black Friday or something bad happened, I want to be able to go back and find out and drill into what actually happened, and caused the problem if I could get some forensic evidence. Because normally recreating it, again, we're just wrong, right? Like we guess wrong as to what the problem was, and we can't drill in and get the right thing.
Going back a little bit to the SLA, I mean, one of the problems I often see when I teach developers is premature optimization, where they think something might be slow, optimization, and as developers, that's something we all like to do, is try and make our code be as efficient as it can be. But like we already covered, making things tuned for performance invariably means adding complexity to the application. And it's sort of like the YAGNI, you aren't going to need it principle here, where until you have a customer requirement that says, I need this level of performance under these conditions, and those aren't being met, you shouldn't be doing anything trying to performance optimize your app. You should be writing it in such a way that you could scale it later, because that's going to be hard to do later. But otherwise, you should be writing the most simplest design that you can extend as possible, I think.
I have a colleague who gave me a good example years ago that I've been using ever since, which was when he was a specialized performance tester, and when he worked with devs, and he said, okay, you have this code you want to write. Which one do you want, the Ferrari or the school bus? Ferrari, yeah, let's make it fast. Okay, now this is what you've got to do. You have a classroom full of grade 10s, and you want to get them across the city to attend an event at the museum. Use your Ferrari. And you realize, oh, it only takes like 1, maybe 2 people at a time. That's a lot of calls. You know what? The school bus is the right vehicle there. Yes, it's slower, but it moves a lot more data. And so the idea of premature optimization is like you can't really know until you have a sense of the kind of data you have to move, how to optimize it. So don't make that choice. Don't look at the functional code and say, this is how I think it should go faster until you've actually seen what kind of load you're going to put on it.
Right, because most business applications, good enough might be that the page just has to respond in a second. There are exceptions. I mean, Amazon and Google, they want performance to be 0. And as close as you can get asymptotically to 0, the better. Because they know that every millisecond they shave off gives them more money.
You just said, yeah, you're going slow as a second. And like, second's pretty fast,
I know. I think most users would be quite happy if their page came back in a second. Now, if the ads pop in like another half second or 2, that's probably okay because they're not worrying about the ads, in my experience.
I always find it fascinating when you have sites where the ads pop up first and then the content comes up.
Yeah, those are annoying.
That's carefully crafted code, though.
My personal metric for bad web page performance is if I'm loading it on my phone and my phone goes to sleep, still loading
before the page is finished loading.
I'm like, can't wake up and go back.
Do it somewhere else.
I'm not going back to that site.
Yeah.
I had a comment a little ways back where you were talking about 3 users and doing the simulated tests. One thing that we've done, which has been helpful, is taking 3 or 4 of your most popular flows, putting those into your load test tool and generating 300, 400, 500, whatever number of, the maximum number of users that your affordable load test tool will generate. And then running your training class. So now you've got this simulated load, which is not testing every case anymore, but the most common ones. And so it's simulating the most common load and the most common queries. And now your real users are going to go and do real jobs that might incorporate many more flows. But they're going to find these bottlenecks because now everything's under stress. And if there is some long-running query that's affected by user management or something else, you will all of a sudden discover it. So it's a way to maximize your test resources. And it's the marrying of the manual and automated methods where you don't take near as long to write those load tests because they don't have to be near as comprehensive, and you let the people do the comprehensive functional tests, and if they run into places where it just doesn't work anymore, now you've actually found something, which is really,
Oh, absolutely. Profiling is a critical part of doing good performance testing. And there's different ways to collect that. If you have a business specialist or someone who understands the target users of the system, then just profile what their common use case scenarios are, and then you automate that, get that into the system. You can start to balance and offload based on peak periods of the day. 9 a.m. on Eastern time, this is the load. At noon, the west coast of North America comes online, and then it increases the load. So you can do the math and work out how those profiles interact with each other to predict certain patterns. And I find that the 80-20 rule, you sort of mentioned the Pareto principle, it comes up quite often. And one of the rules of thumb or heuristics that I use is you're only going to get about 80% of your users will use about 20% of the functionality. So I like to automate that 20% of the pathways through the system and have that running under load, and then we have us as the humans going through the system and doing more of the little obscure paths that are also interesting, and having the instrumentation returning meaningful data to us to analyze later.
So to me, that's the most effective simulated or
yes.
Not real load test situation. That's the best you can do.
Guys, I think we're going to have to call that a show because we're just about out of time. So let's have a big hand for our panel. Hey, we'll see you next time on .NET Rock.
Thanks, everybody.
All right.
We're just about out of time.
Just about out of time, and it's almost time for beer. Almost
We
time.
got another panel to do. What are you talking about?
Yeah, we have a panel.
So those of you that are in here are probably aware that this was switched with Jesse Liberty's Windows 8. We are also switching the next panel which was going to be in the architecture room down the hall, with whatever it was that was going to be in here next, which was Lino. Lino Tadros' talk on portable libraries, I think, something like that. I think that was it. So if you were here to see Lino next, he'll be in the architecture room down the hall. Thank you.